Right, here is the little video for those two questions there. So here we go. A squirrel can run 20 miles per hour and a pig can run 285 meters in 65 seconds. This would be considered a unit rate, just making an observation. This not really, but it's still a rate, right? Who's faster and by how much? It does tell us that they want it in meters per second. Okay, so we need to convert this one. So let's add the squirrel. Squirrel would be 20 miles in 1 hour. We're going to convert the miles. 1 mile has 1.6093 kilometers. You could have also just stated, like if you multiply this by 1,000, right? You can say that 1 mile has 1,609.3 meters. But I will just take that extra step because the miles are gone. 1 kilometer is 1,000 meters. Right? And so you cancel the kilometers, and so you're left with meters. We need to take care of the hours here. 1 hour has 3,600 seconds, right? Cancel those two as well. So you're left with meters and seconds. Let's figure that out. And I get that the top ends up being 32,186 meters, right? And 3,600 seconds. That's our rate. Then we get it to a unit rate, which is 8.94 meters per second. Okay, you divide these two to get that. Perfect. Unit rate, that's how I want it. Just arrow pointing to it. And the pig, we're going to figure that out. I'm going to run out of room here, I'm thinking. So this is I, just to make sure. Right? The pig can run 285 meters in 65 seconds. All I need to do there is divide, right? Top divided by bottom. And you get 4.38 meters per second. This is also a unit rate. Perfect, right? So now you can compare them. And obviously the squirrel is faster. Okay. I'll just make a little note here. Maybe over here, 8.94 minus 4.38. That gives me 4.56, right? I'm just going to do a little cloud here that I did the work. So I would say that the squirrel is faster. Oops. Is faster by 4.56 meters per second. Okay, so that's my final statement. Therefore, I, double I, so I will cut that here, make room here, double I. How long would it take for the squirrel to run 152 meters? Talking squirrel here. So your choice, like, because our end goal is to figure out how long, right, it would take. So you can actually use this, or you can use the converted unit rate to get you started. Okay, so if you go 8.94 meters in 1 second, right, how long would it take you to run, or to scroll to run 152 meters? X number of seconds is what is required. So you cross multiply and divide, right? So it's 152 times 1 divided by 8.94. And so X would be 17 seconds exactly. Just happens to be the case. Okay, there you have it. So that would be your answer for double I. And then triple I is what distance can the pig run in 5 minutes? So I know that the pig can run 4.38 meters in 1 second. Therefore, what distance can you cover in 5 minutes? So 5 times 6, right? That'd be 300 seconds that is being considered here. I don't think I have to show you that. I think you can figure that out. And so that's X number of meters. So we cross multiply and divide. So it's 300 times 4.38 divided by 1. Okay. 300 times 4.38. So that's 1,314 meters, right? That can be that the pig can run. So that answers question D. Hopefully that made sense. I will just maybe make a note here. 5 minutes is the equivalent of 300 seconds. Okay. That's also accurate. Honda Accord has a fuel economy of 8.8 liters per 100 kilometers. How many liters would be required to travel 840 miles? Okay, so we are given a rate. That's how the fuel economy is stated. That's a standard way, but we're giving a distance in miles, and that's kilometers. So I will go 840 miles and just convert that, right, to kilometers. Miles cancel out. So 840 times 1.6093, it's 1351,812 kilometers, right? So that there's that conversion, and then we'll extrapolate, right? Now we can say 8.8 liters in 100 kilometers, right? How many liters would be required to travel a distance equivalent to 840 miles, which is 1351 kilometers, right? So X number of liters, cross multiply and divide 1351.812 times 8.8 divided by 100. And here we get, let me just clear that. So I take the previous answer times 8.8 divided by 100. That's 118.96. 118.96 liters required, right? Required for that trip of 840 miles, right? So we did the conversion. This was step 1. And then this was step 2 here. Right? To do that part, to set up your proportion, given that this is true, you extrapolate, right? And then the second one is actually quite straightforward. If fuel costs this much per liter, calculate the cost of traveling at 840 miles, right? Well, this is what is true. $2.079 for 1 liter of fuel. That's a fact that you're given a rate, right? So you ask yourself, to make this trip, you need 118.96 liters, right? You need the liters. The distance helped you to figure out how many liters are required. So that would be X number of dollars that you would need. Okay, so you again, side of the variables on the right, you start with a number, cross multiply and divide. Okay, so it's 118.96 times 2.079 divided by 1. 118, and I'm using the rounded value. That's okay, because we stated our answer here, so we can use that rounded answer in the next part here. So that's $247.32. That'd be the cost for that trip. So first you have to figure out the liters, and then you figure out the cost. And I can tell you that the cost you can always find by saying liters, right, multiplied by the dollars per liter. That is a short little formula that you can use if you want. It saves you from having to do that. Okay. Hope this helped. I'm going to throw in, I was thinking maybe throwing in the other ones, but I think I'll just scan those and post them in Google Classroom. Okay. All right. Hope this helped. Have a good one.